For this example, we're going to do something a little bit different. Both the actual example and the one off to the side are really good for understanding. We'll start with the one off to the side, and then we'll talk about the regular example as well. So here's a graph of g of x. Sketch and label its image after a compression by a factor of 1/3, then a translation of 2 units up. So if we label the points that we have on our graph, 4 key points here. We've got -5, 3, -2, -3, 1, 0, and 4, 6. So I'm just setting it up. Normally you wouldn't set the whole thing up, but just to get a visual, we'll always do something for our stretches, compressions, and reflections first, and then something for our translations afterwards. Just to remind us of what we're going to do, above the arrows, vertical compression by 1/3, translation to up. So we'll look at where each of these points go. Looks like it's only affecting the y values. So we got -5, 1, -2, -1, 1, 0, 4, 2. And then moving it up, -5, 3, -2, 1, 1, 2, and 4, 4. Lots of simple mental math, so simple that you often do it without paying attention. And once you do it without paying attention, you have a very high chance of making simple mistakes. So be careful, because there's a good chance you're going to make a little mental math error, and then all of a sudden one of your dots is way out to lunch. So when we're going to graph this, I'm going to put my new points on here. I've got, in the end, -5, 3. Oh, that one stayed the same. -2, -1. Or sorry, -2, 1. See, even when you graph them, you can make those easy mistakes. 1, 2, and 4, 4. So that's what I have as my final graph. In order to say, is this reasonable? I'm going to look and I'm going to just go through and say, well, I need my y to be squished by 1/3. And whenever it's by a factor of 1/3, you use your x-axis as sort of the thing that doesn't stay, and everything will get squished towards the x-axis. So does my new graph look like a squished form of my old graph? Not too bad. Now, if everything got squished towards the axis, in fact, if I draw that temporary squishness, I don't know if that's a word, that would be the first thing that we did. We temporarily squished it to there. Then the second thing we need to do is move it up to, does it look like that's what matches up? Yes, it does. Okay? If all of a sudden you have a point that doesn't match, the shape doesn't even look close to what you began with, then it's chances are you've made a mental math error somewhere, and you'll have to check all your work. So although the math is easy, take your time, pay attention to it, because nothing is more frustrating than finding out you've got a little point wrong in there, and then you have to go back and do all your work again just to find where that mistake is. We need to label our graph. What would the equation of this graph be? Well, the 1/3 would be outside of the function, and the +2 would be outside of the function. So now we're going to look and we're going to go back and actually look at the one on the side because there's something that I want to point out in this one. All of the work is shown there. You can look at the solution and read it, but here's the graph of f of x. Sketch and label its image after horizontal compression by a factor of a half, and then a translation 3 to the left. So we could do our points again. We've got our 4 points, -4, 3, -2, 0, 2, 5, and 4, 2. Our first set, and then our second set. So first of all, we're going to multiply x by a half, and then we're going to go 3 to the left. So x by half, -2, -1, 1, 2. These numbers stay the same. 3 to the left. -5, 3, -4, 0, -2, 5, and -1, 2. Based on what we know has happened, does it look like it's been squished horizontally? And then moved 3 to the left? Okay? No, something looks wrong, right? Something looks wrong, which the bottom point, because when you squish it and you move it, it should be down here. So let's see if we can find out where did we make our little mistake. It's kind of hidden. It kind of looks squished, but not quite right. Yes, Andre? My second point. What's wrong with this? Everything seemed right. Zero and -2. Sneaky one. Did I disguise that well so you wouldn't see it right away? Okay. Can you see yourself doing things like that every once in a while and not even noticing it? Yes. Okay, so we got 0, -2, but that's going to change this one. So now when I multiply x by half, it stays 0 and -2. And when I move it 3 to the left, it's now -3, -2. So we're going to put those points back on there. That one matches up at the right height. Now -3, -2 seems to match up. 1, 5 matches up, and -1, 2. Whoa. Perfect. Now, with the exception of that squiggly line being bent, does it look like it's been squished and then moved 3 to the left? Yes. -2 and 5. Oh, that's why the squishy line didn't work? Good eye. It just was fine. I just read it wrong, right? I got, so -2 and 5 and -1 and 2. And then my lines match up better. Good. Now, the reason I wanted to show you this is up till now, the thing has been the same as the other question. It's in writing the equation. When we go to write this equation, when things happen inside the function, because everything is horizontal, everything is affecting the x, then for this one, everything's going to be inside the function. And when we write it inside the function, what you're going to be tempted to do, well, first of all, you have to remember, oh yeah, the half is a 2. 3 to the left would be a +3. And you're going to be tempted to do this, and you're going to feel really good about it. And then you're going to get your quiz or your test back, and you're going to be like, why did I lose marks? because you have to have another set of brackets every time. So as far as how do I, double brackets get a little bit messy. So what I like to do with double brackets, sometimes I make my first brackets big and then my inside brackets smaller. Sometimes I use some brackets square and some brackets round. But lately I've tended to really like the look of big and little brackets, but it's personal preference. So I've been doing big brackets and little brackets, so I can see that this big bracket ends with that big, and you have to have it factored out. So what we're going to do is at the bottom of the page, 221, do you have space under that example still? So we're going to write a special note that whenever you have a horizontal stretch slash compression slash reflection, with a horizontal translation, you must have it in factored form. This only is a problem with horizontal stuff because it's inside the brackets. With the vertical stuff, there's one thing way out in front of the function. The other thing is all by itself far away. It doesn't have an issue. But it does have an issue inside the function. And if we look back to the examples that we did right at the beginning, notice that they have them all in factored form when they gave it to us. But there will be some examples that you do that won't be in that factored form. And you'll have to first change it to the factored form in order to do it.